I'm Beth Pariseau, Senior News Writer at Informa Tech Target, and this is IT Ops Query Season 3 Observability in the Age of AI. StarTree markets a real time analytics platform based on Apache Pinot, a distributed online analytical processing data store originally developed at LinkedIn. StarTree, co founded by former LinkedIn architect Kishore Gopalakrishna, markets a fully managed data analytics service to customers such as DoorDash, Razorpay, and Stripe that need low query latency and high concurrency. StarTree also has a version of its StarTree cloud service for observability in preview that supports metrics, logs, and traces. It shipped StarTree Third Eye last year for anomaly detection and root cause analysis. Gopalakrishna says the observability space is still ripe for disruption. Thank you for being with us, Kishore.
Pleasure to be here, Beth. Thank you for having me on the show.
So, how do you propose to disrupt observability?
Before we answer that question, I would like to talk about the evolution of the observability space itself. And if you go back 10, 20, 15 years ago, I think that's starting with the likes of AppDynamics, Neural Lake, and others. We started off with the APM space. I mean, before it folded into the observability, we focused on application performance monitoring, which was really tracking the metrics, right? And then we also had logs, which was predominantly dominated by Splunk and later on Elasticsearch and others. And traces are the new set of things that are actually coming into this space. So if you step back and then look at what has happened in this space is these systems have been vertically integrated, is in it's all in one solution. So if you pick AppDynamics or Neuralink, you would get an end-to-end solution for metrics and performance monitoring. And if you pick something like Splunk, you would get an end-to-end solution with logs. And similarly for traces and others. But I think for us, it was very interesting to see what was the underlying architecture in this on all these systems. So if you deep dive there, you would see most of them start with agents that are actually collecting these, whether it's metrics or it's logs or it's traces. They are these agents, and these agents do a bunch of things internally in terms of aggregation, in terms of compression, etc. And then they ship the data to a remote location, which is typically people use some sort of a streaming system like Kafka or Redpanda or Kinesis to actually store that. And then from there, you store it into another database or multiple databases, depending on your throughput requirements. And then you have a UI that is custom built for serving the log use cases or the APM or the metrics use cases. Right. So what we really found was like, hey, if you take it apart, the stack looks exactly the same. Yes, there are a few differences in terms of what they actually ship, what kind of data they ship, and what happens in each of these layers. But overall, it's an agent which is collection, and then there is some sort of a transport mechanism, something like Kafka and others. There is a storage layer, and then there is a visualization layer. And what we are seeing more and more customers are realizing that hey, this is the same stack, but we need this data across all these different systems in one place for us to truly have a complete observability solutions, because the logs and the metrics and traces, they're all intertwined. It's very hard for you to go to one system and then to another system, then to another system. And not only that, people are also realizing that this data is actually a lot richer and you can build a lot of other applications on top of it. And so if you put all these things together, it's a lot better to standardize instead of vertically on one for logs, one for metrics, and one for traces. It's better to standardize horizontally, which is you have a bunch of collection agents, and these are already getting commoditized. If you look at Hotel or Prometheus agent, so they're all building their own systems there. And then for the transportation, Kafka, Redpanda, and all these other streaming systems are getting standardized. And for the visualization layer, if you look at it, something like Grafana is being more and more commonly used. I think what is missing there is really the storage and query part, right, which is something that can provide really, really fast performance at the same time be very cost effective. I think that is where we are seeing the gap, and that's kind of how we see the observability market evolve, whether you call it 2.0 or 3.0, whatever number it is. But that's the core idea for us, having a centralized platform that allows you to store logs, metrics, and traces, and in a way that you can actually build variety of applications on top of it. Sorry, that was a long answer, but I kind of wanted to give you a whole picture in terms of this is how we see the stack, and that's how our customers and users also see this evolving.
So, what does StarTree bring to that storage and query layer that isn't available from what's already out there?
So I think it's kind of a expansion on what we have actually built in Pinot, right? I think the core philosophy of Pinot has always been doing less work per query. And if you look at all these systems, be it metrics, logs, or traces, it's all about how can we serve the queries that are coming in with very limited work, right? I think that's the core concept.
Mm.
And the work done per query must be very less. And that's where StarTree and Pinot brings in the variety of indexes that are actually needed to be able to answer these queries in the most efficient way possible. And now efficiency comes in two things. One is definitely in terms of the work done, and the second one is the cost of storage as well. So one of the key things that we have built in StarTree is the ability to run these applications directly on the object store, right? So you don't need a local attached SSD for this, and we have built a lot of innovative solutions on top of S3 where we are able to provide very, very low latencies even for observability use cases. So it's a combination of being able to leverage the indexes that are already there in Pinot, and also the fact that we added the tier storage capability that allows you to store petabytes and petabytes of data at a very low cost and without incurring the cost of local SSD.
Mm.
So I think a combination of these two, plus there is a unique deployment model that StarTree brings to the table, which is bring your own cloud, which is unlike other companies where you need to ship your data to a remote location. You can actually have this within your account and get all the benefits, right? So now this is also adding to the cost benefit because now you're not shipping the data outside, and that allows you to actually save the egress and ingress cost that will be additional on top of the infrastructure cost. So the combination of Pinot, being your own cloud with tiered storage, and the power of indexes in Pinot, I think those are the three main things that allow us to differentiate in terms of what is already available out there.
So, in a way, it's kind of already natively observability 2.0 in terms of the flexibility of the queries and joining the data together.
You can call it that way. I think from the query perspective, we don't want to disrupt that.
Mm.
I think people are used to PromptQL for metrics. I think for the logs, there are multiple variations there. I mean, Splunk having its own log query language, Elasticsearch having its own query language. But I think the industry is moving towards the LogQL standard, and that's the thing that we are supporting there. So it's PromptQL for metrics, LogQL, and TraceQL for the traces.
Mm.
But what we also have on top of it is the standard SQL. So you still can actually write applications that can use SQL, and it can be metrics data, but you can still access it using SQL. So that gives the flexibility for the users to say, I need a Prometheus dashboard, so I can just use PromptQL. I can lift and shift it very easily because we provide a pluggable data source there. At the same time, they can build rich data products, right? And that requires more sophisticated join semantics and etc. That can actually be solved using SQL, whereas PromptQL and TraceQL and LogQL are for simplistic single table query languages. So that's how we think about it, is giving that ability for users to stay in the visualization system that they're already familiar with and the query language that they're already familiar, but at the same time get all the benefits in terms of speed and cost efficiency.
So, when can people get their hands on this? When will this go GA?
We are taking this in phases. I think for us, the first thing that is coming up is both on the metrics and the logs part. So we already have the Grafana plugin where people can actually use the PromptQL. So that is a lot closer in terms of getting to the GA.
Mm.
And the ones that is immediately going to follow up is the LogQL and the log query. So that's where we are also building the Grafana plugin, where people can actually get very similar view as what they would see in any other log query language. So overall, by end of this year, we will have both of them as GA. But the system is already up and running at a large scale. I think for us, the key is we are already having the MVP that covers most of the metrics use cases. Logs is where we are actually focusing on right now.
Okay. And then traces at some point?
Traces, not yet. I think for us, the backend already supports traces, so you can actually push traces and you can query, but we don't have a visualization plugin there, and that's coming down the road. So right now we are focused on metrics and logs.
In terms of the architecture to the uninitiated, which would include me, it sounds a lot like what Dynatrace talks about with Grail. They have a data lakehouse backend and they also are using object storage. They don't do the bring your own cloud part, but otherwise, can you clarify a little bit what makes StarTree a different approach?
Right? It again comes down to the indexes that we have,
Mm,
right, and the storage format. I think that's where we differentiate. So what has happened in this observability market is, if you look at metrics, the way time series was stored was very different early on, because the concept of labels and dimensions was something that was newly introduced, and that kind of made the data structure and the data layout more similar to the OLAP stores.
mm,
That's why something like Pinot and other OLAP stores are becoming a lot more relevant for observability, because people are adding a lot more richer context. So just give you a very simple example. Back in the days, if you want, let's say, revenue number for US, that would be one metric. Revenue number for India, that would be another metric. Revenue number for Brazil would be another metric.
mm,
And now we want to slice and dice on per browser, then you would have another metric for India and browser and US and Chrome. So it just resulted in an explosion in terms of the number of metrics. And that's why in the metrics time series world, they refer to as like, oh, millions of time series. But really, there are only few time series. It just all these things are represented as labels and tags. So you don't really need to store them as different time series. That allows you, and that now becomes much closer to the OLAP data store, which has timestamp, a value, and a bunch of dimensions associated.
mm.
That's where OLAP becomes a lot better storage structure than the traditional. So I haven't looked into the details of Dynatrace in terms of how they're storing, but typically all of the early generation time series database have this structure.
Hmm. Okay.
And I think second, we have built a lot of things for optimizations in Pinot, because if you look at the origin of Pinot, we focused on the external facing use cases, which was like millisecond response latency and lots of concurrency. So we have built a lot of features in that is actually helping even the internal use cases as well. So it's just extension of whatever we have done, and leveraging that for the observability use cases.
Okay. And this is coming at a moment where generative AI obviously has exploded into the mainstream. So, how does that play a role in making observability prone to disruption?
So there are a couple of initiatives that are happening, and this is something that we had started along with Uber even before the AI disruption came in, which is this technology called as CLP, which is a compressed log processing. The idea here is kind of reverse engineering the templates of the logs, and then instead of storing the whole log again and again for every log, you kind of separate them into like, hey, here is the template and here are the variables. And what this allows us to do is, now you can think about running the templates through an LLM, and you can now ask natural language questions. Right? Instead of asking the pure SQL based or following a Lockul or Splunk kind of a interface, you can actually ask natural language questions on your logs. And that will change the way people think about logs. And in some ways, I would even argue that tracing might actually be something that is not needed if AI actually does a much better job in tying different logs together.
Mm,
Because if you step back and look at it, tracing is nothing but you're tying the logs from different systems together. You're tying the logs and metrics from different services by a trace ID. That's what you call trace and span. And it's nothing but how do I correlate all these for a given request that comes from the user? How do I correlate this from one service to another service to another service? But there is always this common ID called the trace ID. And if LLMs can actually do a much better job there by understanding this correlation and then being able to answer these questions well. So I think there will be two innovations that will happen because of AI in the observability space. One is how do you translate the data that's coming in? And one is using this templates, and then but in the end generating an embedding out of that
mm,
event that is coming in, right? Instead of storing them in a structured way or even unstructured way in the raw format, you can actually turn that into an embedding. And then the second one is when the query comes in, instead of having a very structured way of querying, it can actually turn into an NL, natural language query base. And now the data becomes a lot more interesting, and you can actually ask much more interesting questions without worrying about, oh, this is the structure that someone actually pushed in. Because there is a lot of knowledge that you need to know, like this is the structure of log that is coming in. this is the field, this is what needs to be queried. So I think in a way, it opens up and lowers the bar in terms of how much knowledge you need to have before you are actually leveraging the logs and metrics for root cause analysis or debugging some system. Again, there is still a long way to go to get from where we are, but I think this is definitely allowing us to get into that mode where you can pretty much turn every event that's coming in into an embedding. And I think the challenge there right now is the cost of these models are still high. It's not as low as we would like to for running this on an event by event basis.
Mm.
You can definitely run this on documents and other things. That is what the world is doing right now. But you don't see docs getting generated like millions of documents per second. It's more or less static and they don't get updated that often. But now, if you want to move this concept to an event, it's going to incur a lot more cost. We have to wait for the cost of a modeling invocation or like calling a model to create an embedding. That cost has to go down significantly before we can actually do this.
Mm.
The possibility is there, but I think the cost of the overhead, that additional cost that you incur on a per event basis, has to probably go orders of magnitude down before this becomes something that is feasible and also helps in a lot of other use cases.
Can you explain what an embedding is again for the uninitiated like me?
Oh, yeah, absolutely. I mean, I cannot do like go back to the vector model, but you can think of, let's say, person X viewed this page from place Y at this time and did X, Y, Z actions, right? So this is like is structured. Even this is how it actually gets generated. But what happens in today's world is we take out those specific things and says person is a user ID, did X is an action on this browser is a browser dimension. So you convert that event into a structured event. But with embedding, you can basically send this event as it is, and it will generate a, let's say, 768 floats, and that basically encapsulates the context of this. And then it basically understands, oh, this is a Chrome browser, this is this person, this is in Germany, and so those kinds of things will get encapsulated in this. And then now you can pretty much ask more natural language questions of how many people did this and then did this and then did this. So that can be a more natural language expression, and then you can actually match that using the embedding. And that's kind of the idea. Embedding is really turning any event into this world of 768 dimensions or even more if you want to get into.
Hmm.
But the core comes into like how are we generating those numbers, and that's where the models come into picture. So there might be additional tuning that is required to generate the right model. You cannot just probably take a regular model that's already out there and then turn it into it. So there's a lot of innovation that needs to happen there out there that, oh, you can just pick any model. But that's the core idea. This is beyond observability. It doesn't have to be restricted to observability.
Mm.
You can think of every event in the world at some point getting translated as embedding. That makes the challenge 100 times harder than what it is, but that's the exciting thing that we are all looking forward to.
Is StarTree doing any of that work on the models to help tune them?
Not as of now, because the way we are thinking about is more in terms of providing the ability to plug in those models, because there will be tons of use cases. And we don't want to narrow down into one particular use case. So we are more of a platform. So we want others to actually plug in the specific models that can be used from their business context, because there will be variety of use cases. And if you look at security use case, they might have a very different model. If you look at a fraud use case, there's a very different model. Like a threat intelligence will be paying more attention to the IPs that are coming in and the frequency of that and a bunch of other things versus something else more focused on the dimensions of it. So I think once you have this underlying architecture, it can be used for a lot of different use cases. You just have to plug in the right model encoders and decoders on both sides of the pipeline.
Okay. And then throw into this already dizzying mix agentic AI emerging. How do you think that's going to change all of this?
In the observability world, it's going to be fantastic. I think if you take a look at how people are diagnosing any issues today, they have all these. I mean, if you go to any of their Grafana dashboard, like hundreds and thousands of dashboards that they would have created, and each one having like so many widgets. And when there is an issue, someone has to look at so many different metrics. And typically, all of this is someone would have hand coded and written down the run book of, oh, if this alert fires, do this and then do this and then do this and do this. Right? But the agentic model will completely change this, because now you can spawn hundreds of agents in parallel and then say like, hey, just go do all these things and summarize the results for me. So it helps you instead of human going into these 100 different dashboards and keeping all the context in their head and then coming up with this. I think this is a huge value. And I think this is where people have not realized this. I think the number of queries is going to exponentially grow higher on these systems. So I think it's a lot of these systems were not built for that kind of a concurrency and that kind of a throughput. And that's where Pinot shines and it allows you to have these agents because agents are not, they don't have the limitations like what we have as humans, right? Because we can only query one and then comprehend one and next. It's like there is always lag between the two, but not for agents. They just keep sending queries non-stop. And so now system becomes the limiting factor on how quickly it can actually analyze, how much can it actually analyze.
Interesting times, as they say.
Yes, absolutely. Yeah.
Anything else about observability and the near to long term future that you want to mention?
For me, it's the way it's evolving and the data that's getting generated. And what's actually really happening in observability is the domain itself is growing bigger and bigger. Like pretty much everything is in observability right now, right?
Mm.
Even events, the standard events that would be classified as slightly different now is now part of Observe, right? I mean, this call is happening. Obviously, we are not using Zoom or Webex or anything. But if you think about this call, there is so many metrics and events that are getting in. And it's again, it's an observability use case, but it doesn't have to be treated like a Prometheus or a Prometheus metric, but it can be an event with lots of data in it. And that is also part of observability. So it's like pretty much observing any event is under the umbrella of observability. Now that we are trying to translate those into metrics, logs, and traces, but I think you can pretty much generalize it as any event. And I think that's what is going to be the whole umbrella of observability, which is just any event. You can pretty much log in and then be able to query that and then visualize that. So it's going to be a pretty big domain that will encapsulate a lot of different use cases.
How do you think that's going to change business in terms of business observability, digital transformation? What implications?
So that's a great point. I think that's one of the things that's the second order effect of what I mentioned when you start thinking about events as part of your observability is now you can tie the business with the system because traditionally observability has been related to system metrics, which is like what's your CPU, what's your latencies. It's not really thinking too much about the business side of it. Right? That's when what we built for as Third Eye, which is really monitoring the business metrics. So the two worlds, the business world monitoring and the operational world monitoring are kind of always get decoupled from each other. But this will allow them to actually come closer because it's always much better to start your triaging with business impact rather than, hey, the CPU is like 100%. Like, okay, there will be always some CPU that's always 100%. You cannot really triage that. But if you kind of start with, hey, we are actually losing money in this or there is some issue with some customers, then it's a lot easier to start from the impact because you can see that, hey, this is impacting the customer or this is impacting the users. And then go from there to like, oh, this is because this node is misbehaving and it's actually having a high CPU usage versus always starting from the other end because there will be a ton of issues all the time. And that becomes like a alert fatigue. And that's when people just turn off all their alerts and assume that everything is fine.
Yeah, getting to the so what of it,
Yes, exactly.
right? Well, thank you very much for being here and sharing your expertise and really appreciate it.
Thank you, Beth. It was my pleasure.
This has been IT Ops Query Season 3, Observability in the Age of AI. If you have any feedback on this episode or want to share questions, comments, or stories we should consider covering, please reach out to me at beth.pariseau, that's PARISEAU, at informatechtarget.com. Please consider rating, reviewing, and subscribing to this podcast on your platform of choice, and tune in next week for our continued conversations with industry experts about how observability is shaping AI and how AI is shaping observability.